Hey everybody, it's Mr. Canfield. I hope you're doing well. Today in geometry, I'm going to be covering the Chapter 5 review that we did in class. I'm going to cover some important details and hopefully help you build your note card in the process too. So before we do anything else, I'll be writing with our happy little pineapple pen today. Yep, that's important. Okay, so first thing to note, we talked about a bunch of different ideas when it comes to triangle centers. So I want to address these at the outset. So we have something called a median, where if you take the midpoint of a side, and these are, I'm all just kind of rough guessing it, this might be off by a little bit, but if I draw the median, that's called a median because it connects a vertex to the midpoint. And if I took a triangle and connected all three medians, looks like it's right around there. Okay, so, you know, the idea that, okay, I cut that side in half, I cut that side in half, I cut this side in half. If I connect that to its opposite vertex, I connect this to its opposite vertex, and then I connect this to its opposite vertex. So I'm gonna be slightly off with these because I'm, you know, freehanding all of it. But you connect all the medians, that makes the centroid. The centroid is the balancing point of a triangle, meaning I could cut this out and I could balance it on it. It's a little bonus hint for those of you who have watched this video, so for what it's worth. Let's see, so, and one more fact about the centroid, that we're gonna come back to this later, but if I called this A and I called this B, each median is separated into like an A part and a B part. And B is always double what A is. See how that's the little one, that's the big one? So like here, we would call that the A part, that's the B part. So B is double A. So if I talked about the whole thing here, if I wanted to find out what A was looking at the whole thing, I could just divide it by 3 because there's like 3 parts. It's like A and this is 2 A's. So we'll see that a little bit more later. So that's what happens with medians. Next we'll look at angle bisectors. So just pick random. So an angle bisector is where we cut an angle in half. That's my best there. And this is called an angle bisector. And the thing about an angle bisector is, notice this is not always 90 degrees, and it's not cut in half. On this, it was cut in half, but not 90 degrees. When I say not 90 degrees and not cut in half, it can, it just doesn't have to. A median has to cut the side in half, but it doesn't have to be 90 degrees. Angle bisector, it can be 90 degrees and it can cut the side in half, but it doesn't have to. So if we look at some random triangle and look at the angle bisectors, it's about the halfway point of that angle, it's about the halfway point of that angle, and it's about the halfway point on that angle. Cool, all right. So you can freehand these things pretty easily if you've got, I have a little bit of an artistic eye, but not a great one. So if we take these angle bisectors, they cross at something called the incenter. So the incenter, it's always inside, and so is the centroid. The centroid's always inside. The next two we'll see are, it's possible for them to be outside, but what happens with the incenter is there's this circle. Yeah, I definitely didn't get it right, but there's this circle where that's actually the center of the circle, but again, I didn't draw this quite right. And it's called an inscribed. So we got those two. There's 2 more. And these are all things you can find online. I'm just using my own voice to talk through them. So the next special segment we had was called an altitude, and that's where you find a point that, I'm going to use this. You know what? I think I just said altitude. I'm going to instead go with perpendicular bisector because this triangle is better suited for that. It's going to be more helpful. So if I take this side, find the midpoint, and then make a right angle with it. So pretend that's a right angle and draw that up. This is called a perpendicular bisector. So let's talk about how this is different than these two. Both of these we started at an angle. This one we start actually at the midpoint of a side. So this is the only one that starts at the midpoint of a side. It's called perpendicular bisector. It must cut the side in half. It must be at a 90-degree angle. It does not have to cross the vertex.
Walking around and looking, going, where's my bag at?
All right. Hey, have a good one.
You too.
All right. He doesn't know. It's fine. That was Mr. Wilson, if you know Mr. Wilson. All right, so perpendicular bisector does not have to connect to the vertex. So he was our special guest, okay? I'm gonna put a bonus thing on the quiz now, on the test. Hey, who was my special guest during the video? Mr. Wilson. Don't tell anyone, okay? It's just you. It's just for you if you watch this and you found it. All right, so perpendicular bisector does not have to connect to the vertex. Okay, let's keep going. So what happens if we connect all the perpendicular bisectors? So I'll just draw some random triangle and I'll find the halfway point, draw my best at a right angle there, find the halfway point, draw my best at a right angle right there, find the halfway point. Okay, so I missed by a little bit because it's going to be somewhere, it's probably like right here. But this is called the Circumcenter. And what we can do with a circumcenter is we can draw, if we take our compass and open it up and we draw a circle, it's a circle that actually touches all three vertices of the triangle. So this is called a circumscribed circle. So our final form that we are looking at today is, let me draw a okay, I'll do that. Okay, so the last one we have to draw is called an altitude, and that is where you pick a side and you find where you can connect with the opposite angle at a right angle. So that's an altitude. It does not have to cut in half. It does have to touch the angle though. So this one, we could start it at the angle and draw down. So like I could start at this angle and draw down so it meets at a right angle. That. Now, while I'm here, I won't draw the other triangle. We'll do the same thing here. I'll do my best. What is it, right here? So that's our last center. It's where we cross the three altitudes, and that is called the Ortho Center, because the word ortho literally means perpendicular. Okay, so if I were you, I'd have all of these. I drew them pretty big and sketched them out for the video, but that would be something super important for your note card. And yeah, we'll come back to those as we go. All right, so our first question on our review says, which of the following statements must be true? Select all that apply. Okay, so EG bisects DEF. So does this actually bisect this? And so you might go, yeah, of course. It could kind of looks like it, but let's do more than that. So the first thing I notice is that this is a side and a second side. They have 1 and 2 dashes each. Then they share this side here. To me, that shows SSS congruence. So that means that D and F are the same. It also means these top angles are the same And it means that these two angles are the same. But look at these. Look at these. Oh, my hand's in the way. Look at these. I'm on a straight line. That and that are the same. The only way to take a straight line and cut it into two equal angles is, well, it's a 180 total, so it has to be right angle and right angle. That's going to be important in a minute. So yeah, it is cut in half. DEF is isosceles. Isosceles means that two of the sides are the same. Those two are the same. Boom. That's all it needs. This could be the same too. It doesn't matter. EG is perpendicular bisector of DF. Well, let's see. Here's DF. Here's EG. 90-degree angle. Boom. Yep. Last one. DEG is 25. So what we do here is we do our normal, well, those two are equal to each other, so I can say 3y plus 4 is equal to 5y minus 10. Oh, he's messing up my focus, isn't he? All right, well, all right. That was fun while it lasted. He's gone. I hope I didn't mess up I just noticed that now. I'm really sorry if the focus has been messed up throughout the video. In order to prevent that, we will switch over to the grass is always greener pen. All right, so with this equation to solve that, the first thing I would do is make a choice about which way I want to move the x's. These are y's this time, but it's the same thing. If you struggle with it, I do have a recommendation that you take the one on the right and you move it over to that side. I would do that by subtracting 5y from both sides. And this is just a good, you take the one on the right and you move it to the left if there's x's on both sides. Let's see, I do 3 minus 5, and if I'm using my calculator, which is okay if you need to. Let's see. So I'll do 3 subtract 5, and I get -2. So I have -2 y's. That plus 4 comes down. And all that's left over here is a 10 with a subtract in front of it, so that's a -10. So now I'll keep going. I need to get y by itself. I have the -2 and the 4. I'll subtract the 4 first. And because 4 subtract 4 cancels, and then I'll take my -10 and I'll subtract a 4. Notice I only did a single subtract there. I just did minus. We're not doing minus -4 or plus -4. We're just doing subtract 4. I guess you could technically write whatever. Write plus -4, but we didn't. Okay. -2y is all that's left. And then to get the y by itself, we'll divide both sides by -2. So -14 divided by -2. But real quick, if you are following along with this, and you honestly, if I was doing this, so I do 3 minus 5, and then I know that next I'm gonna, I gotta do -10 minus 4, and then I'm gonna divide by -2, so I don't need to retype that in. I can just type divided by -2. All right, so y is 7, and that is not the answer. That is the only one of these I'm gonna do in this amount of detail on this, but if you have questions, feel free to email me if you go through this and you miss a piece. So y is 7, but it asks me what DEG is. DEG. So it's asking me what's this angle right here. So, well, I know that angle says it's 3y plus 4. So I'll plug the 7 into that. And that, again, you can just go, hey, 3 parentheses 7 parentheses plus 4, boom, 25. Oh, hey, look, it is 25. All right, cool. So it's all of them. That's going to be a theme today. I don't want you to be misled, though. The test does not have as much multiple choice as this packet does. Mr. Liu and I have been working to make better tests than these. He has done the majority of the work, to be fair. I have done not as much, but I'm very appreciative of what he's helped with and figured out. Okay. But he's not my special guest in the video. You heard him earlier. Okay. In items 6 to 9, okay, so this is just a definition. It's literally, okay, what kind of line segments are those? Let's see, let's look at all my options. Oh, they cut a side in half, but it's not at a right angle, so it's a median. So, oh, it's medians, centroid, oh, it says it's the centroid. Oh. So centroid, even more. Okay, so AD, so that's this one right here. It says, what is the whole thing if FD, which is just that part to that part, is 5? Well, so remember what we said earlier about medians is that medians are cut into like a one piece and a double piece. So if the small piece is 5, then the big piece is 10. So what's the whole thing then? 15. 10 plus 5 is 15. All right, next. So this one's talking about BE. Here's the F. So this one says the whole thing is 15x squared plus 3y. It looks worse than it is. We want to know the E to F, right? Yeah, okay. So well, what we do know is we know the whole thing. Let's talk about this one. If we knew this small part, the whole thing is triple this small part, right? Because it's a single and a double. So this is a single and a double, and it gets us the whole thing. That means that the small piece is a third of this. If you divided this by 3, it would give you that. So 15 divided by 3 is 5, so you could say it's 5x squared. 3 divided by 3 is 1, so it's 5x squared plus 1y. That would be this piece. And so, right, because if I triple it, I get the big thing. You can kind of ignore the x squared and the y. They're almost like placeholders. Or not placeholders. Sure, why not? They are, it's like apples and oranges. You know, I got 5 apples and 1 orange, or 15 apples and 3 oranges. A little bit of some, a little bit of something else. All right, anyway, so I'm actually asked for this one though, but we know this is double that one. So we divided by 3 to get that one, we can double it to get that. So double 5 is 10, double 1 is 2. So 10 and 2. Look at that, 10 and 2. All right. 9 is literally the same process, just different numbers. So they say EB, which is the long one. So if the long one's 3x, we can divide it by 3 to get the small one, which is just 1x. But it's asking me for EF, which is the longer of the two. So I'll double that, and I'll get 2x. All right, 10. So number 10, list the sides from shortest to longest in M and O. 54, 61, here's M, here's N. Wait a minute. Oh, I don't know what it is. If only there was a way with angles in a triangle for us to subtract, oops, and find out what the third one is. Oh, yeah, you just take 180 minus those two. I got 65. Okay. Which of those angles is the biggest? 65. That means 65 is across from the biggest side. So the biggest side is NM is big. 61 is the medium side, so this is medium. So that's NO is medium. And then 54 is across from MO, which is little. Okay, so, oh, my bad. So, now this is a multiple choice question, and it's asking for shortest to longest. So if it asks for shortest to longest, I do MO, NO, NM. Oh, hey, it's C. So that's that one. I also could have listed these if I wanted and said let's just side N, medium is side M, and the biggest side O. You can use lowercase. And if this had asked for big to small, hint. If this had asked for big to small, hint, then I would have just said O, M, N. Like I just would reverse them. Hint. Oh. All right, I'm trying to make this video worth your time. I mean, learning the material to do well on the test, I guess that should be in some ways its own reward. but I guess I'm just giving you some extra help on top. Okay. All right, let's look at this triangle. We see angle bisectors. I see an isosceles triangle. I see those are equal. Wait, angle, side, angle. These two triangles are equal to each other. Angle, side, angle. These are two congruent triangles. Oh no, that means that right here, oh, these are right angles then. That's gonna come into play later. I just noticed that. One of my students definitely did not tell me that in the middle of class and completely throw me off because I had missed it. I missed this. Before I started doing the question, it's worth me going, do I see any congruencies from previous chapters? That might be worthwhile. Okay, so these are two identical triangles. That means 2m and m plus 7 are the same. I could write this like that. I could write m plus 7 is equal to 2m. It doesn't matter. They solve the same way. So in this, if I was doing this one, I would actually move the m over to this side. Since there's no other number here, it's kind of weird. You could write 2m plus 0 if you want, if that helps you. Or you could write it this way and then just subtract the m from both sides and get 2m minus 1m is m, so m is equal to 7. Oh, we're done. If you do it the other way and you subtract the 2m from both sides, m minus 2m is negative 1m plus 7 is equal to 0. Then you subtract the 7 from both sides, you get negative 1m is equal to negative 7 divided by negative 1 divided by negative 1. You get m is equal to positive 7. It's annoying. So there is some worth in making judgments before you start doing anything and go, what's the best way forward from here? So anyway, m7, that's not the answer. It asks what ln is. Well, I could find out what both of these are. They're supposed to be the same thing. Let's see what happens. 7 plus 7, 14. 2 times 7, 14. What's 14 and 14 together? Or just double 14, 28. All right, so 12 tricked me. I saw it's an angle bisector, so I'm like, oh, boom, because it cuts the angle in half, and I walked away. I missed select all that apply. Look at what else is true. It bisects the side across the street. That makes it a median. It hits at a right angle. That makes it an altitude. Wait a minute. It cuts the side in half at a right angle. That's a perpendicular bisector. It's actually all of them. And you know why this happens? Because it's an isosceles triangle, because that and that are the same. Isosceles triangles, the angle bisector of that side, the median, perpendicular bisector, they're all going to be coming from the same place because of that. So that's isosceles triangles. There's another little hint for you. So that happened because it's isosceles. Which of the following does MO contain? Well, since MO is each of these, where do circumcenters come from? They come from all the perpendicular bisectors. So that happens. Where do incenters come from? They come from angle bisectors. If you're like, how is he getting all this? They're all on there. They're all thin. Angle bisectors turn into the incenter. So every angle bisector has the incenter on it somewhere. Ortho Center, that comes from altitudes, and it's an altitude, so we know that's on there. And centroid, that comes from medians. We have medians. Boom. All right. 16. A frame designer. Very good question here, by the way. A frame designer is making a triangular frame. I'm going to draw a triangular frame. Nobody does this. You're not making a triangular frame. You make a rectangle. Who does that? So they got 18 and 27. I'm purposefully not drawing this to scale. What are possible lengths for the third side? So this will not be multiple choice if I give this to you on the test. On here, possible lengths, there's always a minimum and a maximum. So the fact that they only give me a single for each of these and then they say not possible, none of these are true. So I already know it's C. That's cheating though. Let me actually do the question. So things that we know about triangles, if I add these two sides together, they are more than the third side. It must be true. Oh, it's not equal, sorry. It's not allowed to equal the third side. It must be more than the third side. This is true for all three possibilities. So like if I did 27 plus x, that has to be more than 18. And if I do 18 plus x, that has to be more than 27. All these things are true. So let's start with the simplest one first. What's 18 plus 27? 45. 45 and x. 45 is more than x. So x could be 44, but it can't be 45. X could be 44 and a half, but it can't be 45. Let's look at our next one. 18 plus x has to be more than 27. Well, to find out what x is, just subtract the 18 like it was an equation. 27 minus 18, 9. So x, you have to be more than 9, but you can't be 45. You mean more than 9, less than 45. And the way you find that out is, it's a little mouth, right? The mouth is hungry, and it's always eating the greater one. So when I was a little kid, a Mario game had just come out with chain chomps, and so I would draw the little chain chomp with his little block. But the chain chomp always was going after the bigger one. So that's what I did when I was a kid. Anyway, so 45 is big. X is bigger than 9 here. So one way to write that. Oh, wait. We missed the third one. Let's talk about that. Subtract the 20. Wait a minute. It says 27 plus x has to be more than 18. Think about that really quick. 27 by itself is more than 18. That means anything we pick for this side is going to be fine, because we're not going to. The only way we could make this less than 18 is if x was a negative number, and we don't do negative side lengths. So we're good here. We don't even need to include this one. If you did solve it, I think it's, what is it, negative? Yeah, negative 9. X has to be more than negative 9. Okay, but x has to be more than regular 9 too. So, all right. So we could say that 9 has x has 45. So 9 is less than x is less than 45, or you could say x is between 9 and 45. Either one of those I would take. So you can do the work and then your conclusion, and you're good. All right. So we are almost done here. About a half hour in. Okay, that could be a lot worse. This video could be a lot longer. So this one's tricky. What point of concurrency always lies on the interior of a triangle? So I want to show you let me show you one that. All right, here's one that's going to break one of them. So I'm going to show you the perpendicular, no, the altitudes, So if I do altitudes, so altitude for this one looks to be about there, and I'm actually going to extend it. So here's an altitude. And then the thing is, if I want to do an altitude for this side, I have to find out where this side makes a right angle. It's outside the triangle. So hopefully you can see that these two are actually it's gonna wind up intersecting somewhere over here outside the triangle. So altitudes actually can intersect outside the triangle. So that makes our ortho center, so that's a no-go. With centroid, no matter how you draw the triangle, no matter how awkwardly you draw it, it's always connecting midpoints. It's always connecting to midpoints. So no matter how you drag this around, since it's always these midpoints, it's always going to lie within the triangle. So centroid is always within. And incenter is also the same thing, because the angles are cut in half. They're always going to wind up touching. The circumcenter, is it like this that I can do? So if I do perpendicular bisectors, I was close. There's a way with perpendicular bisectors to have it intersect outside the triangle, like over here. then the circle does something like that. So that was pretty close. So circumcenter also can wind up being outside. All right. Second to last, like, real question. So, because this last one, the very last question is a little bit vocabulary. So let's do, okay. RST is shown below. We have this. Oh, see the angle bisectors? What is this then? In-center, which means that I can draw this circle. That's called the inscribed circle, right? It's a circle, okay? It's an ugly circle. So find the radius of the inscribed circle. So I want to find out, like, how long this is. Okay, well, let's see what it gives me. It says XU is -4y plus 20. That's -4y plus 20, okay. XW, 6y plus 10. Oh yeah, and since these are radii, radiuses, radii, they're equal to each other. So I actually could say -4y plus 20 is equal to 6y plus 10, because the way that you get this circle is you open your compass up, and that are all the same, because that's how the compass works. It keeps the same opening. So if I was going to solve this, I would add the 4y to both sides personally. I don't like having to subtract and get more negatives. So I'd add the 4y, I'd subtract the 10 from both sides. I'd get 10 over here, I'd get 10y over here, I'd divide by 10, and I'd get 1 is equal to y. And if you need help with that, you could also, you could plug this into any solver and see how it does it, and go through those steps and see if you want to do it that way too. Like MathWay, PhotoMath, those kinds of things. I know they exist. That's why you can't use phones on tests. All right. So, so I know y is 1, but I want to know what the radius actually is. So I'll plug the 1, like -4 times 1 plus 20. I'll just plug it into that. -4 plus 20, or you can just go to your calculator, put it 16. And all right. Point X is which point of concurrency? That's going to be, let's see, we got our, well, we got our angle bisectors. Oh, so it's our in-center. And then last question, it says police officer, blah, 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 all these things. He wants to be equidistant from both streets. And he's got these streets going on. Both streets, street, street. If you want to try to find a point that's equidistant from two sides, that's literally just go back to your here, equidistant from both sides. Oh, I don't think I wrote that on here. The one that's equidistant from both sides, it's the in-center on angle. Angle bisectors are equidistant from both sides. And that's the end. So I hope this was helpful, and I'll see you on test day. Bye.